So if you remember, last time we actually used this equation, this set of step-by-step basis to actually deal with a lot of stuff. Similarly, when you want to analyze a system, we want to analyze a force observation system. We're gonna use this thing again. Okay. So if you forget, never mind. So let's go through again. So the first step is actually understand the movement. Okay. So the movement itself is, as I said earlier, you put the mass down with a forcing function. Okay, so hold on a while. If you put the mass down with a forcing function f cosine f omega t, okay, in terms of time, that's the case. And then if you were to put this down, this thing will actually goes down, and then the damping and the spring will actually start to pull this out again. And you pull it down again, and then so you start to go oscillate. So this is our concept of our force vibration. So therefore, if you understand this thing, so we have to draw a free body diagram now. Okay, draw free body diagram stating all necessary parameters. Okay, our V sign, our convention, whether the going downwards is positive, negative. And then most importantly, free body diagram states what are the forces acting on the mass. So again, free body diagram states what are the forces acting on the mass. This is a very important concept because you don't know what the fuck is free body diagram, right? You just say okay, free body diagram, that's all. But it's the amount of it is just to analyze what are the forces acting on the mass, so that you can analyze the forces, okay, and then you can solve for a solution for the forces, for the correct forces to be used, or whatever the case. So with this, you hold on a while. So first step is to draw the mass itself. Okay, maybe I should use a different shape. First step is to draw the mass. Second step, you have to draw the spring, right? So you have a certain minus kx. Okay, and then third step is to draw the damping. While the very convention is saying that V is going down, it's plus, right? If it's going up, it's minus. Therefore, we have minus kx and minus cx. So in this case, the x itself is the distance moved. And this x is different from the x that we're talking about. Okay, it can be this x, but however, yeah, this x, it contains the amount of x distance. So you can say that this is x, this is position x, while the distance between the datum point to the position x is distance x. So it's a little thing, something within something, but nonetheless, yeah. So hold on a while. So the first step is to identify the mass. Second step is to spring, and then third step is the damping factor, and damping. Okay, the damper. And then the fourth step is actually to deduce the forcing function. We have said that it's f cosine omega t. Okay, so maybe so therefore the fourth step is to do force cosine omega t. So let's repeat again. The free body diagram states all forces acting on the mass. So we have a spring force, okay, reaction force against this. If you were to take it, the amount of forces over here will cause a equal amount of forces to the spring and the damper, okay. And then take note also that this is cx dot. This is the velocity of the damper, okay. If you want to ask me why, I also don't know, but yeah. Anyway, so now we have identified all forces, okay, acting on the mass. Are there any other forces acting on the mass? No. Okay. So what's that? So the next step is actually to use summation of moment. to set up an equation. Okay, so our next step is to actually set up equation. So as you can see, what are we doing? We are dealing with the position, velocity, acceleration. Okay, we are dealing with F equals to ma. Do we have any angles? We have no angles, right? As you can see, we have, you can say cosine is angle, but cosine is just a forcing function, that's all. But there is no turning of the mass. Okay, you're not turning the mass here and there, I don't know what I mean, but yeah, so you have to really understand, see how you are, which one, in this course there are only distance and angle. Okay, so we're talking about distance. So angle wise, is another thing. So therefore, as you know, it is F equals to ma. So with this, we'll set up the equation. If you use summation of F equals to ma, you just bring in all those terms, the forces, because it's going down, so we take it as a positive. Okay, and then you summation is plus, so plus minus kx, the spring constant, and minus cx dot. Okay, so cx dot. Therefore, this is summation of forces is equals to mass times acceleration x double dot. Okay, so in order to rearrange, okay, so if you rearrange this equation, you'll get, okay, let's bring this portion here, okay, let's bring this portion here to here. Okay, eventually you will get this equation. Okay, so mx double dot plus cx dot plus kx equals to this, and then you divide, because if you remember in the all previous video, this is a typical step. Okay, typical step is the step you always do. You try to make the second order clear of any coefficient. So you divide by m, you'll get this c over m plus k over m f naught over m. Okay, take note that when you divide everything by m, try to divide it in terms of some constant divided by m, because this is one constant, this is a constant, this is also a constant. So you try to put everything, instead of let's say for this one, right, f naught cosine omega t, you just put like that. So you just put divided by m. So this case you're very hard to identify, right? So this is why typically all we actually write in terms of constant divided by m. So this whole thing is a constant. So you can easily find substitution to it. So talking about substitution, so we know that the main factor is equals to the what do you call it again? The damping factor coefficient, okay, the damping coefficient, and then divided by the critical damping, yeah, the critical damping, the critical damping coefficient, okay. So this one is when your damping factor is equals to 1, okay. So you compare it with some underdamped coefficient, okay, or maybe overdamped, I think. But underdamped definitely is whatever. So take note that the concept of critical and this one is being actually said it in video lesson, in lesson 3, most likely the damping cases. So if you were to watch this video, you understand the critical damping thing. So let's come back here. So we know that this damping factors can be illustrated using this equation, and then the natural frequency, if you were to take away the square, is equals to k over m, if you remember. So we take these two relationships, okay, and then we just rearrange. So you know that c over m, so c over m is the c naught is 2 mass omega n, okay, it's not pi. Okay, so from here, since you know that c over m, so you just bring 2 and omega n outwards. Okay, so you have c over n as a representative of this one. So this is why we have this over here. Okay, so and then you know that the natural frequency squared is equals to k over n. Okay, So you just rearrange. Okay, so eventually you will sub in, you have this equation over here. So just to come back again, okay, when after we rearrange this equation, this equation is in your data sheet. Okay, it's under the force vibration. Okay, it's the same thing. So I didn't bluff you. Okay, you just double check. This thing is the same as this. Okay, so nonetheless, if you know that this is being provided, you can straight away jump into here without setting any equation, unless you're called to do force, free body diagram. Nonetheless, this is pretty easy to set up, and then take note that this is so-called the non-homogeneous equation, while this is homogeneous. This equals to 0, this is equals to f naught cosine omega t. So this thing is the same as this, okay, and then you have a forcing function. So this is why it is a forced vibration. It has a force acting on the mass constantly, pulling it down and up, pulling it down, whatever. So yeah. So with this concept, okay, with this equation, we can actually solve. So this is our equation already, I think. So summation of moment to set up an equation. So this is find ways to simplify the equation and get answer. So this is our equation already. So we have to find ways to actually simplify this. So I'll leave it to the next video, and or maybe next two or three videos. Okay, and then yeah. So I'll leave you to with this equation, and we'll do it. Bye bye.